Okay, given the function f of x equals root x, then plus 1, please notice the plus 1 is not inside the radical. Find f of 25. Okay, so to find the value of this function using the input 25, we would like to know what output we get. Everywhere there's an x, we're going to replace x with a 25. So we're writing f of x equals root x plus 1. However, everywhere there's an x, we're going to just replace with a 25. In some sense, you could say I took what's right here and I copy pasted, and everywhere there's an x, I just did a search and replace on the computer. It's not what I really did, but you could pretend I did, and every x is now a 25. Now let's simplify. The root 25 becomes a 5. To have this equals, I still need to write the plus 1 even if that hasn't changed, and that's going to be a 6 in the next step. Given the function g of x equals cube root of x plus 10x, find g of 8. Again, we're going to write what's here. We're going to write this g of x equals cube root of x plus 10x with some replacements. That's all. Every x we encounter is going to become an 8 instead. So we'll have g of 8 equals cube root of 8 plus 10 times 8. Cube root of 8 is 2, right? So you've got to, if you're comfortable with square roots, but you're feeling uncomfortable with cube roots, be sure to always go back and look at how the slide started for this day. You've got to think about setting up things based on the definition of radical that we started with. Okay, so it's because so cube root of 8 is equal to 2 because 2 to the third power equals 8. And then after the plus sign, 10 times 8 simplified to 80, and we'll get 82. So given the function f of x equals root x minus cube root of x, find f of 64. Again, there's 3 x's, there's an x on the left, there's 2 x's on the right. Just replace all of them with 64 as one line down. So f of 64 equals root 64 minus cube root of 64. The square root of 64 is 8. The cube root of 64 is 4. And so 8 minus 4 is going to simplify to 4. Okay, given the function g of x equals square root of x plus 9, the x plus 9 entirely is inside the radical, so the plus 9 is not outside the radical. Find g of 16. By the way, let's look at this answer in quotes. So what's incorrect about this? Let's just kind of analyze. If somebody took g, okay, so you should take this and replace, basically copy this down with the replacement that every x should become a 16. So g of 16 equals root 16 plus 9. And then there's a 4 plus 3 equals 7. You should pause for a moment and think about what's wrong with that. What happened here is it looks like root 16 plus 9, sorry, let me say that faster, root 16 plus 9. It looks like there's a skip step where somebody turned that into root 16 plus root 9 in that skip step, and then that became a 4 plus 3 because root 16 is certainly 4 and root 9 is certainly 3. The problem is within the skipped work, root 16 plus 9, that shouldn't become root 16 plus root 9. That's using this false formula. So what's a correct answer look like? The final answer shouldn't be 7, by the way. Instead, so this first step of this work in the red box is actually correct. Okay, that's a correct application of the function. It's just distributing the square root was using this false formula. That shouldn't have been done. Instead, you'll have your root 25, which is equal to 5. Given the function h of x equals x to the 3 halves power, find h of 16. Well, just replace take the function definition. There's an x on the left and an x on the right. Just replace both with 16 first. Then we'll deal with this 16 to the 3 halves power in a moment. This takes a little bit of creativity, but this 3 over 2 exponent can be rewritten as 1 over 2 times 3, right? Or times 3 over 1. So think about 1 over 2 times 3 over 1. If you multiply straight across, you get 3 over 2. The reason to do it in this fashion is now we can apply one of our exponent rules backwards. So if you had 16 raised to a power, parentheses raised to another power, like 3, you could rewrite it sort of one step back as 16 to the product of those powers. So we're just applying an exponent rule sort of in the reverse fashion of how we typically would. But then we can isolate and focus on what's inside the parentheses. 16 to the 1 half power, another way to write that is the second root of 16. I didn't write the little 2, but remember that if you have a fraction as the exponent, so you have like a 1 over 2 as the exponent. So 1 over is key, but then that denominator 2, that becomes the little number outside the radical, which just wasn't written in because you don't have to write it for second roots. And then we'll simplify the second root of 16 to be a 4. I still need to copy that 3 exponent because we haven't done anything with that yet. And then finally 4 cubed is 64.